I'm Chancey Fleet. I identify as capital B blind, and I've been doing 3D printing and 3D design for a few years now. I'm the Assistive Technology Coordinator at the New York Public Library's Andrew Haskell Braille and Talking Book Library, and I'll be guiding you through some 3D printing and design concepts. Today, I'm going to be talking to you about Simplify 3D. There are a few different ways to use slicer software accessibly. One of the most accessible slicer softwares I've found is Simplify 3D. So let me get the painful bit out of the way first. This is not a cheap program. It's $199 US at the time that I record this in October 2023. Simplify 3D, though, is very user-friendly. It is a graphical user interface that is very, very well tagged for screen readers. So there will be few things that you cannot do with a screen reader, with the exception, of course, of a couple things that are technically challenging to do right now with a screen reader. And that includes to observe how your model is resting on the bed, resting on the plane, and to observe the results when you rotate your model. So when it's time to do those two things, use your visual interpreter of choice, whether that be a human being near you, your AI, if you're into that these days, Be My Eyes, a volunteer, or your commercial interpreter of choice. There will be those moments when you have to do that. If you need to check your rotation, if you need to check your scaling, those things that would be represented by a graphic on the screen, we don't quite, most of us have the technology yet to observe those things in real time. And that is not really the screen reader's fault, nor is it the fault of Simplify 3D. But what Simplify 3D does do, though, is provide you with controls that are very well tagged with the use of screen readers so that you can fine tune your 3D printing settings, set up whatever machine you want to set up, control things like layer height and speed, introduce support structures, and manipulate things like scale and rotation. And of course, prepare your model to be printed, save your model to a drive, and the all-important, find out how long it's going to take your model to print. All three of the 3D printers that I use, a Lulzbot Taz 6, a couple of Ultimaker 2s, and a Bamboo Labs, all feature inaccessible slicer software that comes with them. So Lulzbot and Ultimaker come with Cura, and the latest versions of Cura do not work with screen readers very well at all. As of now, as of October 2023. And Bamboo Studio, even though it's a really great 3D printer and I love it so much, sadly, the Bamboo Studio interface may as well not exist from the perspective of a screen reader. So the great thing about Simplify 3D, and I'm using version 5.1 point something right now, is that it has a very, very long laundry list of machines that it works with. And that happens to include the Ultimaker series, the Lulzbot series, and even the Bamboo Labs series. So I can access any machine that might otherwise be inaccessible with the slicer software that it came with. If you're not familiar with what slicer software does, it takes a 3D model, an STL file, and converts the parameters of that file into the moves and actions that your particular 3D printer can make and take. So we're all starting from the same STL file. Let's say, what did I print last week? I printed a small, very cute garden snail. Had never felt what one of those felt like in real life before, and it was fun to explore one. Let's say I printed a garden snail. So the garden snail comes at a particular scale that is specified in the STL file, and it has all of its features, but there's a lot of things that we don't yet know when we create an STL file because we don't know what kind of 3D printer the individual is going to be using. We don't know what kind of filament they're going to be using. The slicer software prepares the STL file for a particular 3D printer. So it specifies the diameter of the nozzle that's being used. It specifies the diameter of the filament being used. It specifies how quickly the nozzle is going to extrude and how quickly the tool head is going to move and at what temperature the nozzle is going to be heated to. It specifies whether or not the bed will be heated. And it specifies the mechanical moves that your particular 3D printer is going to make. Some 3D printers raise and lower the bed. Some, like the Lulzbot, actually move the bed on an axis as part of the 3D printing process. It's going to specify the specific moves that your tool head is going to make. It's going to specify some things that you're going to set depending on the type of filament that you're using. So that's where the temperature comes into play. The maximum speed, which is both a factor of the particular 3D printer that you're using and also maybe the filament type that you're using. Some cool down more quickly than others, so sometimes we have to print at slow speeds. The slicing software is also going to take care of the properties of your particular 3D print that you get to control that are not written in stone into your STL file. So for example, we have layer height. With a fused deposition modeling printer, that's one that lays down filament one layer at a time, you are going to get better resolution, a more realistic feel, a less lined feel, if you will, if you're using a lower layer height. But since your FDM printer is laying down one layer at a time, twice as many layers, a lower layer height is twice as many trips through the entire XY path of that 3D print. So if you have a lower layer height, that means that your print is going to take a lot longer, potentially twice as long. So layer height is something that you can control in the slicer software. Scale is something that you can control. STL files come at a default scale, but depending on what you're using your 3D print for, you may want to scale up, you may want to scale down. Slicing software will help you take care of that without having to modify the original STL file, which is really, really important because most of the ways that we create and edit STL right now are graphical, are CAD-based, so that is not something we would have to want to do as blind people. Another one that's really, really important is the idea of infill. So imagine the inside and the outside of an ice cream cone, a waffle cone specifically. On the outside of your waffle cone, things feel pretty smooth. They feel pretty solid and continuous. But when you get down to the bottom of your waffle cone, you're going to find that the cone is not composed of solid pastry. You feel that honeycomb waffle texture inside. Infill is the interior part of a model, the part that you cannot see because it is surrounded by solid layers. Most models have an infill that might be around 20 or 30% quite often, unless the model needs to have structural integrity, needs to stand up to some rugged use. It's typical that your infill might be down around 20 or 30%. Infill gives you two gifts. When you don't have a solid fill, it gives you the gift of time. The lower your infill percentage is, the lower your print time is going to be. The other thing that happens is it's going to cause you to not waste your filament. So if you have a solid model with no infill, that's going to take far more time and far more filament. If you're using infill, such as a honeycomb structure on the inside, you are saving a lot of filament, and you're also skipping those areas. You're not filling in those areas, and so it's going to cut way, way down on your printing time. So this is the importance in a nutshell of your slicer software. You control what your 3D printer mechanically does. You tell it what kind of filament's being used. You control factors like heating. You control factors like speed, but you also can make some customizations to your model, such as scaling, layer height control, and infill. And there's more to it than that, but those are the basics. This is why you care so much about your slicer software, and it can make or break your experience with 3D printing. You start up Simplify 3D. You are going to get the option to select a language. Go ahead and do that. I selected English and I moved on. The next thing that I received was the option to use the migration assistant because previously I was using Simplify 3D version 4. I selected no because I wanted to show you all what a fresh install looks like. By the way, if you ever go take actions that you regret and you're not sure how to undo those actions, you can go into the help menu and choose reset all settings, and that will reset to a fresh install. Bear in mind that when you do that, it also resets your account login, so you best hope that you remember your password before you take that step. You can always log into the Simplify 3D website to manage your licenses, see whether your licenses have been activated, and retrieve your password if that's something you need to do. A quick note about Simplify 5 versus 4. I'm using 5. I love 5. Simplify 3D version 4 had a color to height converter. So I might have a grayscale image that I could turn into a height map, and that would be an STL with raised features. Either the dark or the light features could be raised. And this was useful in some scenarios where I wanted to experience a tactile graphic with a lot of depth. It didn't work well on every image, but it worked well on a number of things. I'm sad to say that Simplify 3D version 5 has retired this feature. There are a lot of online color to height converters that will create an STL for you. Some of them are free. Not all of them are accessible. I really miss having this built into the interface, and so I keep a version of Simplify 3D version 4 on my machine, and I believe that as a customer you can download version 4 and install it on your machine, and the two of them can coexist peacefully. So if color to height is important to you and you want to play with that tool, you may want to get yourself a copy of version 4. Moving on from there, I'm going to go to the configuration assistant and set myself up to use the Ultimaker. So I'm going to go into the menu bar. One thing that kind of hurts me is that you can't use Alt with the arrow keys to get to the things that you need. You've got to just hit the Alt key and arrow over, so be aware of that.
File, edit, view, mesh, repair, collapse, supports, tools, collapse, help, collapsed.
So I'm coming into help, and I'm going to find the configuration assistant.
About, check for software, configuration assistant.
And I'm going to press enter on configuration assistant and get myself into the workflow for setting up a printer.
Configuration assistant dialog. This wizard will help you configure the software for your 3D printer. Click next to retrieve a list of available profiles and select the best one for your machine. Next greater button.
Now I can search for my 3D printer of choice. I'm going to type in Ultimaker and arrow down.
Ultimaker. Ultimaker.
I'm going to have to press enter actually to get to my list of printers.
Ultimate list.
I tab once to get to the list.
Ultimaker 1 list item focused.
And there's a bunch of them here. I have a 3 beside me.
Cancel list. Ultimaker 2 go. Ultimaker 2 go list item. Ultimaker 2 go list item. List. Ultimaker 3 list item focused selected.
So I'm experiencing a strange little screen reader artifact where if I arrow down, it is not reading the name of the 3D printer. And if I use my current read current field command, my screen reader key with tab, it's not updating. But if I tab and then shift tab, it updates me and gets me to the right place. I'm using NVDA today. I'm using version 5.1 point something of Simplify today. This may impact you and it may not. If it does, just tab away and tab back. Sorry about that. So I've picked Ultimaker 3, which is the printer that I have.
Cancel but less back but next greater button enter.
I'm tabbing over to next and pressing enter on that.
Finish button enter. Cancel less back button enter.
And that's it. I can read my dialog box to confirm that I've done what I needed to do.
Simplify 3D left parent. License to Chancey Fleet right parent. Window. Configuration assistant dialog. The software can now be successfully configured for your 3D printer. Click finish to finalize the setup process. Happy printing. System.
Thank you.
Finish.
So I'm going to go to finish and press enter.
Simplify 3D left parent. License to Chancey. Edit process settings dialog. Process name. Select profile layer item info. Edit focused process 1.
Don't do what I have done when I first started using the software. It's offering me by default process 1. If I have multiple 3D printers, which I do, or if I have processes that I'm going to use for different reasons, like my regular process, my default process, and maybe a fast process, give it a meaningful name. So I'm going to call this one Ultimaker 3 regular.
Regular. Combo box Ultimaker 3 down.
So Ultimaker 3 is going to be the printer that I'm using.
Select profile. Combo box.
And that's the profile that I'm using. So I'm using my previous item with NVDA to read the label that's above this combo box, select profile. The way that you do that will depend on the screen reader. I'm using a NVDA with a laptop, so I'm using NVDA, shift left arrow.
Select profile.
And right arrow.
Combo box Ultimaker
to find
3
things.
down.
But that's previous item, next item. So that's all good. We're going to use that that profile.
Update profile button. Save any modified settings for the selected. Save as new button. Save button. Grouping. Show advanced button. Enter. Grouping.
So most of the options are hidden in advanced. So I'm going to hit space on show advanced.
Select models button. Enter. Custom zones button. OK button. Extruder tab control.
So there's several options here. I tabbed several times to get to sort of the category tabs for settings. The first one is extruder.
Layer tab.
Then layer.
Additions tab.
Additions.
Infill tab.
Infill.
Support tab.
Supports.
Temperature tab.
Temperature.
Cooling tab.
Cooling.
Speeds tab.
Speeds.
Output tab.
Output.
Scripts tab. Other tab. Advanced tab.
Scripts, other, and the advanced within advanced, which is must be pretty advanced. So I'm going to go back to extruder.
Layer
So here I am on the extruder tab, just to give you a little bit of a warning or a cause for excitement, depending on who you are. There are lots and lots of settings in here. Sometimes when you download an STL from someone else, they will give you specific printing tips for that nozzle. Sometimes when you're using a particular brand of filament, people will give you particular tips for that brand of filament that might touch on some of these advanced settings. 90% of the time, you're not going to change these. You're not going to worry about them. But if you do get guidance on changing advanced settings, or you want to experiment with the results of changing advanced settings carefully after first having saved your default process, this is one of the places where you can go. This is the extruder tab. I'm not sure that we're going to go through every single tab, but I want to give you an idea of what some of the advanced settings are and what they mean and how you read the information about them with your screen reader. Okay.
Add X button. Enter. Remove extruder button. Enter. General grouping. General grouping. Combo box tool 1. The tool number for the selected extruder will be used. General grouping. Spin button 0.40. The diameter of the hole at the tip of the nozzle.
So you can change the nozzle diameter here if you're using a non-standard one.
Ultimaker 3 left parent. Modified right parent. 0.60. 0.50. Ultimaker 3. Ultimaker 3 left parent. Modified right parent. Ultimaker 3. Spin button 0.40. Focus the diameter.
So I'm on 0.40.
General grouping. Spin button 0.90 controls the flow rate for extrusion.
Flow rate. Some of these are quite advanced. You can keep tabbing through them if you want to. I won't go through them all. This is where you control the extruder for which you are changing the settings right now. So your choices are
left extruder, left extruder,
left extruder, or right extruder. So
right extruder.
Mine defaults to using the right extruder. And you'd see different options depending on your 3D printer. I have a dual extruder Ultimaker 3. So one of those extruders can be used for support and the other for regular filament. Or I can use both extruders for regular filament, perhaps in 2 different colors. Typically, I just use one extruder for most models, so it's important for me to just take note of which one I'm using and make sure that I am adjusting the settings for the one that I think I'm adjusting settings for. So I have chosen my right extruder, and I am going to tab into the settings now.
Add extruder button. Enter.
I can add an extruder or remove one. No need for me to do that.
Remove extruder. General grouping. General grouping. Combo box tool 1. The tool number for the selected extruder will be used for tool change commands. Down.
That is pretty technical. I believe it refers to the commands that are in the STL file. Don't quote me on that. It's not something that we tend to need to change.
General grouping. Spin button 0.40. The diameter of the hole at the tip of the nozzle.
So extruders come in different diameters. The Ultimaker 3 defaults to 0.4. If you take a look at your extruder, your tool head, and when I say take a look, you can check what it is that you bought on Amazon or your marketplace of choice. You can check what it is that comes standard in your 3D printer if you got your 3D printer standard, or if you need to, you can get up close and personal with your tool head using your visual interpreter of choice. And there are somewhere on your tool head, there will be labels telling you about the diameter in millimeters of your extruder on your tool head. And of course, your extruder is what feeds the filament out. And right now I'm at 0.4 millimeters, so a pretty narrow one. So I can change that by arrowing up or down. There's no need for me to do that right now, but I can confirm that that works with a screen reader.
General grouping. Spin button 0.90 controls the flow rate for extrusion movements. Higher values will extrude more plastic.
This is called the extrusion multiplier. So this controls the flow rate. Imagine that you're turning on a faucet. How fast is content, in this case filament, flowing through that faucet? The higher this number is, the more material is going to come out at a time. And the plan that your slicing software makes for you based on your STL is influenced by your rate of extrusion. It does not say extrusion multiplier. My screen reader doesn't read that to me. And this is a place, and there are some places in Simplify 3D where the setting is labeled in a funny way. If you have a touchscreen laptop, this might be a great time to take a walk around with your touchscreen and explore the labels on top of these boxes. What I actually have to do to read the label above this is use my previous item with NVDA.
No previous.
It says no previous, and that tells me to go to the parent group. So I'm using NVDA shift up arrow because I'm using a laptop.
General grouping.
And then I'm going to try going left.
General grouping.
And then going to the child group.
Extrusion multiplier.
And there it says extrusion multiplier.
General spin button.
If you have no idea what I'm talking about there, it pays to spend some time getting to know how your particular screen reader handles interaction. So NVDA uses a sort of granular interaction where a control may have children or small controls within it. The control may have parents. So for example, this entire extruder dialog box belongs within the parent or possibly the grandparent Simplify 3D. And you've got to spend some time reading your screen reader's documentation to figure out how your screen reader handles going to the previous item, the next item, items contained within, or items that are the container for where you are. If I went into all that in detail right now, we would be here for a very long screen reader workshop instead of just a tour of Simplify 3D. So if that's confusing, take a moment to sidebar and get to know how your screen reader handles interaction, because while very accessible, the way that things are implemented in Simplify 3D can sometimes be a little bit of goofy, and we may sometimes have to do a little bit more of the interaction two-step than we wish we did. So that's our extrusion multiplier. I'll show you a couple other things in here. I just want to show you how much there is. We're not going to go through every single item, but there's a lot in here to explore.
General grouping. Automatic radio button not checked in automatic mode. The software will automatically determine an extrusion width based on your nozzle parameters. Set to manual mode to enter a custom value.
So the extrusion width is going to be determined automatically by your slicing software by Simplify. There's no reason why you should want to change this unless you're getting very technical with the way that you're going to do your 3D print. Get some guidance before changing this.
General grouping. Spin button 0.40 the desired width for a single plastic extrusion. Ooze control grouping. Ooze control grouping. Use retraction checkbox. Check temporarily reverse the direction of the filament at the end of an extrusion to reduce stringing and oozing.
So ooze control is when at the end of a layer, at the end of a line that's been laid down, the extruder is going to suck the filament back in so that it doesn't leave behind a little string. That is called ooze control. And I could keep tabbing. There's so many more options in here.
Ooze control grouping. Spin button 6.25 how far to reverse the filament feed during a retraction movement.
That's how many millimeters in it will pull back. I think that's in millimeters.
Ooze control grouping. Spin button 0.00 how much additional filament to prime on top of the original retraction amount. Use negative values to prime less filament than was originally retracted.
Pretty technical, probably no reason to change that, but there it is. All of these sliders and checkboxes and edit boxes are fully accessible.
Ooze control grouping. Spin button 0.00 how far the extruder should lift after completing each retraction movement. Ooze control group.
So you can set it to lift away after retracting filament to further prevent any stringing.
Ooze control grouping. Spin button 1500.0 the speed that the filament is retracted.
That is the speed at which the filament is retracted.
Ooze control grouping. Coast at end checkbox check. Turn off the extruder a short distance before the end of a loop to relieve pressure in nozzle and prevent blobs.
All right, that prevents blobs.
Ooze control grouping. Spin button 1.00 how far away from the end of a loop to stop extruding and begin coasting. Ooze control grouping. Wipe nozzle checkbox not checked. Continue moving the nozzle around the completed loop to wipe any excess filament on that loop. Edit search, blank.
And that's it. We're back to our search box where we could look for a specific setting, and it's going to circle around like most dialog boxes will until I'm back at the category tabs.
Auto-configure for material grouping. Auto-configure for material combo box plot down button. Auto-config but auto box ultim edit selected Ultimaker 3 update profile save as new button. Grouping. Hide advanced, select models, button end, custom zone, OK, but can't, extruder tab control.
And I'm back to the extruder tab. So in a minute, we'll come to show advanced, and I'll give you a tour of some of the advanced settings, but let me show you what's in the basic settings.
Select models, button enter.
You can select particular models to apply your settings to, but right now we're not doing that. Right now we're defining a default process.
Custom zones, but OK, but cancel, but general settings grouping. General settings grouping. Spin button 0.1500 is thickness for each layer of the print.
This is the thickness for every layer of the print. Another way of saying layer height. So if you make each layer thicker, you're going to have more tactile and visible striations, those telltale stripes that let you know that something was definitely 3D printed. Depending on what you're going for, that may be worth the trade-off. And the trade-off is that your part is going to take less time to print if your layers are taller. If I'm making a tactile graphic, if I'm making a bas relief and I want smooth, delightful curves, or if I'm making a model of something that is primarily aesthetic in nature, maybe I'm making a miniature, or I'm recreating a piece of cuneiform, like the ones that we have in the collection of the library where I work, I'm going to make the sacrifice. I'm going to make my layers pretty thin. And so I'm going to have less striation and more faithfulness to quote unquote the original or the ideal. If I'm running a test print and I just want to know that it's what I designed fundamentally, or it's something that I'm just going to use, it's very utilitarian, like maybe I just need to make a ruler, or I just need to make a cable manager. I really don't care if that has visible and tactile striations. I may make this layer height higher. And that's why it's a basic setting. It's something that you may play with a lot without too many negative consequences. And this is one of the most powerful places where you can make a change and it's going to affect your eventual print time.
Ultimaker 3 left parent, modified right parent.
Sometimes when I arrow up or down, it echoes the name of the printer, but if I use my screen readers, read the current field command, it should behave itself. So I'm going to use NVDA tab in this case.
Spin button 0.2000 focus this thickness for each layer of the print.
So 0.2 millimeters.
0.2500.
Quarter millimeter.
0.3000. 0.3500. 0.4000. 0.4500. 0.5000.
Half a millimeter. I would hesitate to go much higher than that, but you can. So that's where you control your layer height.
General settings grouping. Slider 30 the desired density for the inside of the part. Lower values will cause the infill lines to be spaced further apart.
So this is the density of the infill. We talked about infill earlier. The default here is 30%. Depending on what I'm doing, I may bring that down to 20%, even 15%. If something needs to have more structural integrity, I may raise that. I learned the hard way that if I'm making a flat, wide, postcard-like tactile graphic, the layers on the bottom need to have a lot of infill. Otherwise, when I attempt to peel it up from the bed, if I'm not very, very careful, it may shear. So that would be a situation where I would need more infill. If you're going to be exposing a part to stress, maybe you are designing a tactile puzzle and people are going to be pulling and yanking and angling it, consider using a higher infill. If you are making something that's just meant to be gently touched and explored, like my little model of a garden snail that I made last week, you're probably okay with a lower infill. Oftentimes, if someone else has designed the STL, they will tell you recommended infill settings. This is another one where lowering your infill percentage can make your part lighter. It can make more use of the filament that you have, and it can bring your print time down. But remember, that is at the expense of how much wear and tear and torque the part can take. So I'm going to tab past that.
General settings grouping. Spin button 30 the desired density for the inside of the part. General settings grouping. Slider 30 the desired density for the inside of the part.
Oh, so they give me a slider and they give me an edit field. I get to pick which one I want to use. Okay.
General settings grouping. Spin button 30 the desired density for the inside of the part. General settings grouping. Use Raft checkbox not checked. This option will create a solid structure below the part to help with adhesion and provide a clean level surface to begin the print.
So this is kind of a cool thing. The raft is like a little bumper that gets added to the bottom of your part. And it's usually pretty easy to peel away because it's only connected at the periphery to the rest of your part. So you can usually clip it away or even pull it off. And it tends to help with situations where your initial layer might curl up and create some blobbing and ruin your print. So if that's a problem that you're having, consider adding a raft. It's a type of support structure. So I'm going to tab now.
Auto dash configure for material grouping. Auto dash configure for material combo box plot down.
So what type of material are we using? Right now, all of my defaults, even when I go into my advanced settings, the defaults are going to be there for me to explore. So even if I'm not going to change my advanced settings, by the way, I may look through them just to see how things are happening behind the scenes. Right now, we're auto configuring for PLA.
Apps.
If I arrow down, I have all kinds of exciting choices of auto configurations to do. PLA is great all-purpose filament. It's pretty ubiquitous. It's great for most applications. Not great for things that require a ton of torque withstanding. And I'll point out a couple others here that we could use.
PVA, nylon.
So nylon filament is pretty cool. It's kind of bouncy and stretchy. So if you are making a part like a soft phone case that you want to conform around something, you may want to use nylon.
Pla left parent, right. Nylon, pla left parent, right, not pla.
And those are actually all of the options that are in here. There's ABS, which I won't go into because I'm not super prepared to explain it right now. I primarily use PLA, but this is where you can go to get other options.
PVA.
And PVA is a soluble support filament that you can dissolve in warm water. And so the support just kind of magically melts away. That's kind of cool if you have a product that needs support, a part that needs support, and you don't want to have to sit there and trim it off.
Pla. Button. Auto dash configure for quality grouping. Auto dash configure for quality combo box medium down.
So this is awesome. You have medium,
high.
You have high quality, which plan on your print time doubling, and you have fast. I don't care if it's aesthetically pleasing. Please get it done so I can check my work, see if I want to print this model again, see if there's anything I need to model. If you're rapidly prototyping, it will be more rapid. If you choose fast, for most applications, medium is fine.
Medium.
If you want a finer level of detail, please choose high, and then you can go in and further tailor in the advanced settings.
Button. Auto dash configure for extruders grouping. Auto dash configure for extruders combo box right extruder only down. Button. Edit selected Ultimaker 3 red combo box Ultimaker 3 left parent. Modified update profile button save any modified settings.
And now I'm going to circle around to the advanced settings.
Save as button. Grouping. Show advanced button and.
So I'm back in my advanced settings. We've gone through extruder.
So custom zone. Okay, but can extruder tab control.
I'm going to go to the next tab, which is
layer tab.
Layer. And this is where I can specify my layer height and also what happens at the bottom of my part and the top of my part. I mentioned earlier that when I'm printing tactile graphics, I've learned the hard way that there needs to be a couple layers at the bottom of my part that either have a lot more infill or don't use infill at all, that are solid. So that may be the case for you if you have a part that needs to stand up to wear and tear. So it's a good thing to learn about your layer settings.
General grouping. General grouping. Combo box right extruder. Choose the main extruder.
So again, I'm choosing which extruder we are talking to, which extruder we are addressing right now.
General grouping. Spin button 0.5000 is thickness for each layer of the print.
So I set this pretty high. I did that in the basic settings a little while ago, and it's reflected here in the advanced settings. This is where I determine my layer height, and we're at 0.5, which is pretty chunky. It's going to make a visibly striated part where every half a millimeter is a new layer. That is a lot higher than standard. And again, I would do it for rapid prototyping when I really, really don't care about that visual or tactile striation effect.
General grouping. Spin button for the number of solid layers to create at the top of the part.
So by default, we've got 4 solid layers at the top of the part. That's so your part doesn't get easily crushed or damaged. It's got 4 solid layers with no missing parts before that honeycomb or other style of infill begins.
General grouping. Spin button 3 the number of solid layers to create at the bottom of the...
At the bottom, by default, we have 3. I'm going to up that to 4, knowing that sometimes I do bas relief and that 4 will really pay.
4. General grouping. Spin button 2 the number of perimeters that trace around the outline of the part.
So the perimeter is the outside of the part, and that includes the perimeter, the very outside of the part, and any interior perimeters. So let's say that I make a figure 8. The perimeter includes everything around the outside track of that 8 and both of the donut holes in that 8. We want a certain number of solid layers there, again, so that the part isn't damaged if it experiences some rough and tumble in life. So 2's probably good for most applications. If you're looking for something that has more structural integrity, though, you're going to want to increase this.
General grouping. Single outline corkscrew printing mode left parent, face mode right parent, checkbox not checked print a single continuous spiraling perimeter by gradually incrementing the Z-axis. Note: using this option will force 0% infill with one perimeter only.
So that is a different printing technique. I am not fully conversant in when you should and shouldn't use it, but you could read up on corkscrew vase style printing if you want to. I have not used it myself yet.
Adaptive layer height grouping. Adaptive layer height grouping. Enable adaptive layer heights checkbox not checked. Modify the thickness of each layer based on the model geometry. Larger layer heights will be used when there are no large overhangs or complex features.
So this seems like a smart thing to do. I'm not sure why it's not checked by default. I'd like to experiment with checking it. So I'm going to go ahead and do that with the space bar. So it'll use geometry to determine when it can get away with a larger layer height when there aren't any complex features that would interrupt or cause a consequence for having a larger layer height. I think that sounds interesting. I would like that.
Checked. Adaptive layer height grouping. Spin button 0.1000 the smallest layer height that will be used when the model has severe overhangs or significantly complex features.
So if there are complex features, a smaller layer height can be used. This lets us know how small at a minimum we can go. And so I'm not going to change that. I don't understand enough about when that should be used to change it on my own yet. I would go do some reading, do some Google searching before making that change because I don't understand what the consequences might be.
Spin button 0.3000 the largest layer height that will be used when the model has vertical sidewalls and no complex features.
So vertical sidewalls and no complex features, what is the largest layer height that would be used? It seems to me like I could increase that and spare myself some print time, but I'm going to read up on it more before proceeding.
Spin button 5 determines the intensity of the smoothing that is applied to adaptive layer heights to avoid abrupt transitions.
More reading to do.
Dimensional adjustments grouping. Dimensional adjustments grouping. Spin button 0.00 the distance to offset the outer boundary of the part, not including any interior holes or cutouts. Use negative values to shrink the boundary.
So there's more to this. I'm going to rapidly tab through these until I get back to my category tabs.
Dimensional. First layer settings grouping. First layer settings grouping. Combo box percentage. Choose if first layer properties should be entered as a percentage of nominal or absolute value. Start point selection. Start print in order. Print in order. Auto edit combo update profile save button grouping hide advanced button select models custom OK layer tab control.
And I'm back at my category list. So this next tab is called additions. I'm going to tab now into it.
Skirt/brim grouping. Skirt/brim grouping. Use skirt/brim checkbox. Check this option will print several loops around the outside of the part to print the extruder and help anchor the part to the bed.
So this is going to print several loops around what eventually will be the perimeter of your model. But that filament that gets laid down is not going to touch your actual model. So true confession, I was not sure about the utility of this. So I literally did a Google search and said, how does it help a 3D print to print a skirt if the skirt or brim is not touching the model? Because I did not understand. And so I couldn't make an intelligent decision about whether to check this box or not check this box. And Google served me up an answer that the purpose of this is to prime the extruder to make sure the extruder is working correctly and to establish a smooth flow of filament. So I take that to mean it's making similar types of moves to the type of moves that are going to be made in my actual 3D print. Because it's not touching my model, it's going to be easy to remove because it's literally like an outline traced around the real thing, and it's not necessarily touching the real thing. So when you come across these settings, there's usually a little explanation here, but if that little explanation isn't enough, don't underestimate the power of opening up your search engine of choice, typing in some information, typing in your question, because if you're asking yourself that question, somebody else has before, and your answer is probably waiting for you. And a lot of this stuff is just unfamiliar because you haven't come across it before, but it's not actually all that technical if you just take a minute to look it up. So now I know that, yes, I'd like to use a skirt.
Use skirt/brim checkbox focus. Check this option will.
It's checked. I'll keep it checked.
Skirt/brim grouping. Combo box right extruder. Select the extruder.
The right extruder is going to print my brim.
Spin button 1. How many layers of the skirt will be?
I will get one layer. So if I'm having a problem with extrusion, and I want to give more time to the extruder to sort of get primed, get warmed up, maybe I want to increase that to 2, perhaps.
2.
I use the up arrow to do that.
Spin button 4.00. How far away the skirt outline should be from the surface of the part?
It's going to be a whopping 4 millimeters from the part. And I rudely interrupted my screen reader. I love to do that, but it would have told you, had I given it half the chance, that small values will mean that my skirt and my brim, if I want, will directly attach to the part. But remember that this is not a raft. A skirt or a brim can be pretty solid. So if it attaches to the part, prepare to have a fairly permanent perimeter outside the perimeter of your part that you would really have to do some work to clip away.
Spin button 2. The minimum number of loops that will be printed around the outside of the part. If quote all extruders quote is selected, each extruder will print this many loops. Raft grouping. Raft grouping. Use raft checkbox not checked. This option will create a solid structure below the part to help with adhesion and provide a clean level surface to begin the print.
So this is our raft. We talked about our raft before in the basic settings.
Prime pillar grouping. Prime pillar grouping. Use prime pillar checkbox not checked. Create a pillar that is used to prime the extruder after a tool change command.
So a prime pillar is a little home base that your extruder goes to just extrude some filament in a safe little zone, a safe space, if you will, that's not going to ruin your part. So if there's any oozing, if there's any stringing, any blobbing, it can work it out with the prime pillar and then return to the print. And that's helpful if you're using multiple extruders. That's what a tool change is, changing the tool head, i.e. the extruder. When the new extruder gets fired up, it's time to go visit the prime pillar. I'm using one extruder, so this is not going to apply to me.
Ooze shield grouping. Ooze shield grouping. Use ooze shield checkbox not checked. Create a shell around the part to prime each extruder after a tool change and catch excess filament oozing from inactive extruders.
So the ooze shield is kind of another type of a brim, but it is a place where excess filament can be wiped off. Again, it's a safe place where that wipage is not going to impact your beautiful 3D print. So if you're having problems with oozing and clumping, messing up your print, and you're using multiple extruders, Maybe turn on the ooze shield.
Edit search. Blank.
And that's it for additions.
Awesome.
All right, I've right arrowed to the infill tab. I'm going to explore it.
Sparse internal infill grouping. Sparse internal infill grouping. Combo box right extruder. Select the extruder that will be used to print the internal infill down.
So we talked about infill. It is the structure that is a non-solid that you cannot see when the part is complete. It is on the interior of the part. So I'm going to tab this again. We're talking about the right extruder right now. I can change that if I want to. I don't need to change it right now.
Sparse internal infill grouping. Combo box rectilinear. Choose the pattern for the internal infill layers down.
So there are all kinds of infills, and you can read up on the pros and cons of each one. Right now, I've got rectilinear. That would be lots of little rectangles.
Grid.
We can have a grid, which is going to be lots of little squares.
Triangular.
Triangular.
Sinusoidal.
Sinusoidal.
Wiggle.
And wiggle, that I will not claim to understand. I'll be looking those up.
Fast honeycomb. Full honeycomb.
And then we can do a fast or a full honeycomb. I believe those are probably octagonal.
Octahedral.
Octahedral.
Cubic.
Cubic.
Gyroid.
And gyroid. So look these up at your leisure. Rectilinear and honeycomb are pretty typical to what I've seen used frequently.
Wiggle. Grid. Rectilinear.
I'm going to stick with rectilinear for right now. I'm going to tab now.
Sparse internal infill grouping. Spin button 0 the additional rotation angle offset to apply to the internal infill pattern. Use a value of 0 to match the default pattern.
So you can rotate that infill. So you could have your squares oriented with respect to the model more like diamonds if you wanted, by angling them 90 degrees. I don't have a reason to do that right now, but if it's recommended by the person that designed your STL or you'd like to experiment, you can do that. And you can also read up on the structural properties of different infills and when you may want to apply rotation.
Sparse internal infill grouping. Spin button 30 the desired density for the inside of the...
We talked about this. This is the density for the infill. Right now we're at 30%, which is relatively high. And up it if you need more structural integrity, lower it if you need a faster print, and the part will be used gently.
Sparse internal infill grouping. Spin button 150 the width of the infill extrusions relative to the outline perimeters.
The width of the infill extrusions relative to the outline perimeters.
Sparse internal infill grouping. Spin button 1 use this setting to print multiple infill layers at once for faster print times.
So you can print multiple layers of infill at once. So for example, you could make your infill 2 or 3 layers tall to cut down on the print time. If I'm using a higher level of infill for structural integrity, I think I would choose not to play with this too much, but you can if you want to.
Sparse internal infill grouping. Spin button 35 the percentage of the infill extrusion width that will overlap with the outline perimeters to help create a strong bond between these features.
So there needs to be a strong bond between the infill and the perimeter of the part. If your infill stopped right where your part began, you could create a situation where your part would just whoop, shear right off of the infill the minute that some pressure was applied to it. So you have to have the edges of your infill sort of sinking in and becoming one with the perimeter of your part. By default, they're going to overlap 35%. So that's good to know.
Sparse internal infill grouping. Spin button 5.0 the minimum length of each infill sequence that should be printed. Shorter infill sequences will be skipped to save print time.
So if there's a really short infill sequence, so for example, you could only fit 3 little triangles in the space that you're trying to fill, the slicing software will just decide, hey, it's not worth the extra time that it's going to take to print these 3 little triangles. We're just going to print solid filament here because the time saving in this scenario does not exist.
Dense internal infill grouping. Dense internal infill grouping. Spin button 0 the number of dense infill layers to print below the top solid layers. This can help ease the transition from the low density internal infill to the high density solid layers.
So this is another thing that I believe can help with torque. So in between the solid layers on top and the solid layers on the bottom and the sparse infill, the primary infill that will be used, you can use a denser infill. So infill that is more solid than the sparse infill. And this is saying that it can ease the transition in between the solid layers and the infill layers.
Dense internal infill grouping. Spin button 50. The desired density for the dense infill that exists right below the top solid layers.
And I'm going to skip past the rest of this and go to my next category.
Solid layers group. Solid layers grouping. Spin button 20. Solid layers grouping. Spin button 0.0. Use this option to expand the solid infill regions within the print to provide increased strength for neighboring features. Solid layers, top layer, ironing, edit search, auto button, edit, update, save, button, group, hide, select custom, OK, infill tab, sparse infill tab,
and we're back. All right. I'm not going to go through the rest of these dialogues in detail at this juncture, but I am going to tell you a little bit about what you will find there.
Support tab.
Support. So we've already talked about brims and how they can help prime your filament. And we've talked about skirts and how they can help with bed adhesion. They can help your part not curl up on the first layer and ruin your print. And they can also help with removing the model in a smooth way. Sometimes we're going to want to print things that need another feature called a support. So imagine that you are printing a small model and the small model contains an archway. At some point, it's going to be easy for the 3D printer to start that model. We're going to lay down the rectangles to the side of the archway, and we're going to, with each layer, instantiate that curve. We're going to start building up the archway, and it's going to start curving inward. And that's not going to be a problem right away. But when we get to the top of that archway, at some point, we're going to be asking the extruder to draw filament across a space where there's nothing below it. And depending on the filament you're using, the 3D printer you're using, the speed you're using, at some point the extruder is going to have trouble doing that. It cannot print across empty space for more than a certain distance before that print starts to collapse. And that's where supports come in. One of the most powerful things your slicer software can do is use geometry concepts to automatically determine what kinds of little pillars and structures it can build under any potentially collapsing part that might be trying to print across space or might be an overhang, so that the support structure can give it what it needs to continue that 3D print smoothly. The support structure is usually attached very lightly and not attached at all points, so it's very easy to clip off or tear off. Some models will use a second type of filament, such as PVA, which is the dissolvable, soluble support. And so you can, in the support tab, define the special characteristics, the advanced characteristics of the supports that you'll be using. It's important to note that in many cases, taking a rational look at your model and being wise about rotation can sometimes be an alternative to using supports. So in my case of the archway, if the part was square and flat on the top and it had an archway, if we were to rotate it so that the flat top became the bottom of the print, we would not need to use supports anymore to build the archway, because we'd be building a U shape and we would not be printing across open space at any point. So always ask yourself before you instantiate supports, because they're going to add to your print time and your filament use, whether rotating the part would give it more structural integrity on which to print, but then use supports if you need to.
Temperature tab.
Next up, we have temperature. This is where you can control the precise temperature of your heated bed and the precise temperature of your extruder. And your extruder, of course, is what heats up your filament. Oftentimes, different brands of filament, different brands of PLA, for example, may work better at 10 degrees higher or lower Celsius than the manufacturer recommended default for your printer. Oftentimes you'll get advice about altering the temperature of the heated bed. This is where you can go in and tweak all of those settings.
Cooling tab.
This section is about cooling. It pertains to the fans that surround your extruder.
Speeds tab.
Speeds. So you can drastically increase your printing speed, but there are a lot of things that can go wrong when you increase your printing speed. Depending on the filament that you're using, it may not have cooled down completely by the time the tool head gets back to a layer that it's laid down. And so at high speeds, that might cause globbing and stringing if your filament isn't fully cooled or hardened. You may have some shaking that increases your error rate at high speeds. And you may have other trouble that's based on high speeds. So typically, the outer limits of what your 3D printer can do mechanically, and that's something that you can go online and look up in the specs, are not recommended for most 3D prints. So always read the forums, read the advice about recommended speeds in addition to the maximum technical speed for your 3D printer, and realize that maxing out your speed oftentimes will not give you the time saving that you think it will, because it's going to cause lots of errors in your print.
Output tab.
This next tab, Output, refers to what kind of code file is going to be created for your 3D printer. I'm using the Ultimaker, so it uses G-code. There are other items in here like FlashForge. You can read up on what kind of code your particular 3D printer takes. 9 times out of 10, you're not going to change this. What your 3D printer takes is what your 3D printer takes with respect to the type of code.
Scripts tab. Other tab. Scripts. Other advanced tab.
And we are going to dispense with scripts, other, and advanced for now, but you can explore them on your own. The important thing to note is that all of these settings are fully accessible.
Cancel button, OK button, enter.
And at long last, I'm shift tabbing twice, and I'm going to go to the OK button with space. All right, now I am finally ready to import my model and prepare to print it. So I'm going to tab over and make sure I understand which process I'm running. At this point, I only have one process, so I'm just showing you how I do this. I'm not in a menu, I'm in the main screen. So you see, if you see the cube on which your model can be rendered. I'm going to hit the tab.
Remove button, array, center under, tree view. Ultimaker 3 regular row 1 1 column 1 level 1.
That tree view has my processes. So if I wanted to pick a different process, I could arrow up or down here. If I wanted to edit this process, maybe change my printing speed, maybe tweak my infill for this model, I would just tab.
Add button, delete button, edit process settings button.
For that edit process setting, but there's no need for me to do that now. So I'm going to continue to tab until I find import.
Prepare to print, checkbox not checked, checkbox. Import button, import 3D models from disk.
I'm going to import a 3D model from my disk. Okay, I'm going to press space on import and pay a visit to my
Import
downloads
3D
folder.
Model, preview. Chancey, start, downloads left.
I have a model, I don't know if it's any good yet, of a tactile compass.
Items, last week, today grouping expanded. Tactile line, compass line. Items view list. Today grouping, images checked, files checked 1 of 2.
I'll choose files.
Flat line, tactile line, compass, items, flat line.
And I'll choose flat tactile compass. I'm going to press enter.
Simplify 3D left parent, licensed to Chancey Fleet right parent, window. Cross-section list grouping. Tree view. Not checked row 1 column 1.
And it now should be showing me a visual preview of the model. I am going to get ready to save it to a flash drive. I have a flash drive right here, and I'm going to plug it in.
Remove button, erase the selected 3D models from the...
So I tabbed, and the first thing that I get is remove. If I want to remove the model from the canvas, I can hit space or enter. It is important to note that your canvas is going to contain a 3D model, even if you exit Simplify 3D and come back in. So tab around, find the tree view that says...
Import button, import, remove button, tree view. Flat line, tactile line, compass row 1.
Models. It's the only tree view other than the processes one. And arrow through it, make sure there are no models there. If you select a model and tab and hit remove, that'll remove the model.
Import button, remove button, center and arrange button, pack the models together and center on the middle of the build platform.
So if I have multiple models, let's say that I am making Braille game pieces and I am printing, I don't know, A through J Braille blocks. I can hit center and arrange. This button will automatically pack them close together but not touching and center them on the build platform for the most efficient possible printing, because we wouldn't want them scattered all over the place. We wouldn't want the tool head having to take trips it doesn't have to take. So if you're printing multiple models, which you might do so that you can set it and forget it and walk away, rather than just running an A block and 10 minutes later running a B block and so on, you might use center and arrange. When you do that, the first few times that you do it, and definitely when you do it with a new model, check with your visual interpreter of choice that the centering and arranging has gone according to plan.
3 view. Center and arrange but 3 view. Ultimaker 3 regular 011
There's my process setting again.
Add button, delete, edit, prepare to print button begins slicing.
And this is where the magic happens. This is prepare to print.
Checkbox not checked model transforms.
If I pass that, we're not going to go over this now, but we will in another section. Model transforms. Transform is a fancy word for move it around. Move it up, move it down, move it left, move it right, flip it, rotate it. Those are all transforms. You can use the keyboard to transform and move things around. You're going to have to work with a visual interpreter to assess your results in real time. It's a quick, simple be my eyes call. No CAD expertise required. But the actual keyboard moves are accessible with screen readers. We'll go over that later.
Checkbox not check support structures.
This is where you can go to invoke support structures. Not every model automatically comes with supports. Supports are up to your slicing software. If you check this box, it would reveal settings for your support structures.
Checkbox not check cross section.
Cross section, I believe that's just going to reveal visually a cross section of your model.
Checkbox not check machine control panel.
Your machine control panel, if you're printing directly to your printer, I'm not, I'm using a flash drive. You can see things like your bed temperature, your extruder temperature, and all that good stuff.
3 view. Flat line tactile.
And that's it. So I'm going to shift tab a bunch of times past those checkboxes. Oh, and I should have said that transform also includes scaling. So I'm going to shift tab.
Check, prepare to print button begin.
And this is where the magic happens. Prepare to print. I'm going to hit space. This is so easy. You won't believe it.
Feature type. Detailed statistics button.
Once the print is prepared to be printed or exported to a disk, I'm on this button that says detailed statistics. And again, this is a place where it depends on your screen reader. If you're using JAWS, you're probably going to need to use the JAWS cursor. I'm going to use my NVDA read previous item because all the good stuff is above me.
Scroll bars 1. Process count.
Process count 1. So I'm using one process.
1. Model count.
I have one model that I'm printing. And of course, I'm reading the item and then the item's label because I'm going up from the bottom. I could go to the top and come down, but I'm keeping it simple.
15. Layer count.
I have 15 layers in my model. Not so many layers.
2.51 mm. Build size Z.
My build size on the Z axis. How tall will it be? It'll be about 2.5 millimeters tall. This is good to know.
119.25 mm. Build size Y.
On the Y axis, front to back, toward me, away from me.
119 point build size.
119. So that's just shy of 5 inches.
24.59 mm. Build size X.
And on the X,
24.59 mm.
It's going to be about an inch. Yeah.
Build size 0.14. 0 hours 27 minutes.
And here's what I really want to know. My print time.
0 hours 27 minutes.
0 hours 27 minutes. So that's how long I can expect that the print will take.
Build summary.
And that's my build summary. So I am now going to tab to save this to a disk.
Show and begin printing on machine. Export build file to disk button. Save the current.
Space.
Save toolpaths to disk dialog. File name : combo box collapsed. Edit Alt plus N selected flat line tactile line compass.
And I'm going to shift tab.
Preview. Chancey start of downloads left.
And find my
music,
flash drive.
Video, my Dropbox and the Sanctus kit evaluation. Chan 1 of end of quick access. This PC USB drive left parent. D : right parent.
There's my D drive. I'll press enter. I'm going to tab back over to the file name.
Names, file name.
And press enter.
Simplify 3D left parent. License
saving.
to Chancey Fleet right parent. Window. Export build file to disk button. Save the currently previewed build file to disk.
And I'm done. So now I'm just going to tab one time to get to exit preview mode.
Exit preview mode button. Exit the build file preview. Prepare to print button.
So
Begin.
I'm back at that screen that has my models, and I am going to do my future self a favor and remove the model so that I don't forget that it's there and end up printing two things next time I come in.
Checkbox. Remove. Center. Preview. Add. Preview. Ultimaker 3 ready. Add. Delete. But edit. Prepare. Checkbox. Checkbox. Preview. Flat line. Tactile line.
So there's my flat tactile compass. I'm going to tab over.
Import button. Remove button. Erase the selected
I'm going to hit
3D models
space.
from this. Import. Checkbox.
And now there's no tree view.
Import.
There's just a, if I tab to it or shift tab to it, it's just a quiet blank space.
Center
and my model is gone. I'm going to leave now with Alt F4.
Zoom window.
And now it's time for you to test drive Simplify 3D 5 yourself and let us know how it goes.